So this is data science concepts, and this task is about analyzing avocado sales data in the US. So I've got a data set that is in this CSV file called avocados.csv. Avocado.csv. So in Python, I'm using Anaconda environment and I'm using JupyterLab. So in here, um, I've just issued this command to import pandas. Pandas is a library, and it is used to modify, change, prepare data for analysis. So I've just imported it as PD. PD is another short form of pandas. So I'll be using, because I've declared imported as PD, I can use PD dot and use this code here. So that's to read data from this file, this CSV file. So I've created a data set here called C1 data. That is because this project is C1. The task is C1. So here the instruction says we are supposed to multiply the total volume and average price columns. Now there are if let me see, did I display anything? No, there's a if I want to display if I want to display this this particular uh, data frame that I've just defined here, you can use this command, or I can just type. I can just type C1 data. That's first one. I can do that, and then it will display this whole table. But if I wanted to display only the top 5, I can use this. It's only displaying the top 5. This is without any conditional formatting or sorting. It is only displaying what is in the data set. So that's the data set. That is the information that is in the CSV file, the avocado.csv file. It's about 1.9 megabyte. So this is the data set that I'm working on. So I'll just remove this. So from the total, I can use display as well, and it will give me the same thing. Or if I want to put that in here and say display only 5 or only 6, it will do that. So 6, the indexing in pandas, it starts from 0 to 5, so this is all six rows. So we are supposed to multiply the total volume. Total volume is this column here and the average price. Those two columns, we are supposed to multiply them and create another column on the right hand side. It will be called the estimated revenue. So if I come here and I've just created this here. So estimated revenue. If this is only displaying this new variable here, top 5 revenue. It's only displaying this, so we can create data frame out of this data set. This is the whole data set. That's what's in the CSV file. So from that we can only pick out the top five. Yes, the top five out of this based on the estimated revenue. So if we multiply this column, the average price and the total volume, we get the estimated revenue, which is not in here at the moment, but it is in um, yep. If we display it here now, if we display, let's say, if we display C1 data now here, um, let's say, it should display two tables, I think. Yep. So this is the new column that we've just created. On the top one, it doesn't exist. So we've just issued this command here in square bracket. It created this column based on this calculation, and that is total volume times average price, those two columns. So we've now come up with estimated revenue for each row, and we picked up the top five. As you can see here, estimated revenue. Yep, we've used ascending equals false to display, because if the difference is if we put it in ascending order, if we say ascending is true, it will display the smallest estimated revenue in the top. Let's have a look. It's supposed to. Nah, that is this one. That is this one. That is this one. That is this one has changed. If I say false here, false, this table will change because I'm using top 5 revenue, and I'm displaying top 5 revenue down here. The top one here is for the top one. It doesn't show any difference. So if we now change, now if you can see here Miami and all this, Buffalo, whatever, it will change to Northeast, Western California, while this still remains the same because we haven't applied sorting in the top display. It's showing the data in this one, but with the estimated revenue column added. So we don't need that. That is not required for our task here. So I'm going to remove this and only show the bottom table. So that's it. And yeah, this is very, very useful for analyzing data, for cleaning data, for removing unwanted data or omitting unwanted data or displaying data in graphs like this to um, explain it better, to see the visual of it. That is very useful, this tool. So yeah, here I calculated the mean, median, and the standard deviation. The mean here is the average of these five top avocado producing regions: California, Great Lakes, Mid-South, Northeast, and West. These are the top five producing regions, and the mean is the average. Average is what you get when you get the sum of all the counts and divide it by the number of counts. That's when you get the mean or the average. The median, you get it by arranging all the counts from the smallest to the biggest and taking the middle number. So that is the middle number. And the standard deviation tells us the difference in the data spread. If the data is spread, if if the standard deviation value is high, that means the data collected is not standard, which could mean there were very big variations in the data collected. Every count was not the same, or there's a big difference in the data that is uh, that we analyzing. And a smaller standard deviation value, this column here, would tell us that data is a bit consistent. There's a very small variation between the collected counts or data. So it tells us um, if the standard deviation value is very large, it shows inconsistency. That means data is changing a lot. If the value in this standard deviation is small, it shows that the data is consistent. That tells us some good information about the for example, the mean or average value. It the standard deviation compares the value against the average value. If the if the uh, if the standard deviation value is far from the average value or well below the average value, it will show that big difference. If the standard deviation value is closer to the mean or the average value, it shows that there is consistency. So that's how data scientists interpret this data. So we can also use coding in Python to give us this small display here. It only shows us the type of avocado, conventional and organic. Those two types, those are the only two types in the market in this data set. So it shows the mean price or average price for all conventional type avocado and organic type avocado, and the median price, that's the middle value price. And below here we compare the the sizes of bags. The farmers pack the avocados in different uh one, two, three different sizes of bag. One is small bags, the other one is large bags, extra large bags, and we compare it against the total bags. So we get these three graphs here. So that the top three producing regions, based on the total volume they produce, West, California, and South Central. And now we further compare those three regions based on the total bags. So for conventional type, West is the produces the highest number of bags, followed by California and South. And for the organic type, West is still leading, and South, Central, and California sort of fall behind. This uh, missing data here as well. It shows that South Central and California do not accept or do not deal with extra large bags. You see, there's two zeros here. It also reflects here. If we are calculating the standard coefficient variable, it shows this kind of label here. This is for not a number because there's zero here. And we can tell that there's no number here. So this is all the information that is sorted in this order. So this this table here displays the mean and standard deviation for small bags, for large bags, and for extra large bags, and the total bags. And it also displays it on the right hand side as percentage. So that's it for this video. Hope you enjoyed and have a nice day.